That's pretty much it, so I guess we can start with the first project.
Good afternoon. My name is David. I did most of the wiring and soldering in this project, and then Dale did most of the part of the programming, and then Hudson did research, and then Dan actually did probably the majority of the programming. And I'm here to tell you about our project, an autonomous automatic landmine detection system. Many parts of the world still have leftover landmines from conflicts, and generally the way people clear it is by sending someone out in the field with a handheld metal detector to find it. Our goal is to replace that person and have a machine do it. So to do this, we had a Wild Thumper 6-wheel drive chassis, which gives us all-wheel drive and off-road capabilities. We are going to control it with an Arduino microcontroller. We have navigation will be handled by inertial positioning with a gyroscope accelerometer combo. Have ultrasound to avoid obstacles in the way. And then the metal detector will be attached to an arm that will sweep in front of the vehicle's path. Once metal is detected, the vehicle will stop. It will determine if it is a large quantity of metal, and then if it is, it will mark it. So our marking system will be a nozzle attached to the arm that has a reservoir on the chassis that contains whatever marking agent will work best for this situation. We haven't really decided that yet. Once it's marked, the vehicle will travel around the obstacle or the landmine and then continue in its original path. Our goal is to have it automated as much as possible, so that way the user only has to specify the dimensions of the field, and then the vehicle, the robot, does the rest. So, I mean, one advantage of this is it has the potential that you can have one person control multiple vehicles in such a much larger field, whereas with metal detector you can only have one person doing one thing. This kind of sums it up. Is there any questions at this time?
What is a non-metallic mine?
Unfortunately, our system right now is only focused on metallic mines, which are the majority of landmines right now. The non-metallic is something that we have to look into as a future project.
So it's going to pick up anything metal that's buried. So somebody's got a coffee can full of change buried.
Yes, so to detect that, but I mean, the goal would be to try to train it to tell it, this is a landmine, this isn't, and I mean, it will mark whatever it finds as long as it's big enough. So then it's going to be up to somebody else or another robot down the line to actually dig it up and determine if it is a landmine or not. All you know is that there's a potential landmine there. Yes?
This is mounted on a transport of some kind, operated by a joystick?
No, it will be autonomous. So you'll just input the length of the field and it will drive down that. It makes its paths and do most of the mapping and everything.
Positioned by GPS?
We haven't decided what the absolute positioning is, but we'll use inertial positioning to determine like if it's driving straight or not, or turning. Yes?
So obviously your accelerometers and gyros are all going to drift, and then time you hit a bump, you're going to basically steer
Yes.
off to another direction. So you're going to have to figure out how to recalibrate to get back on track.
Yeah, we have another system that we're looking into to give us an absolute positioning, but we're going to do triangulation with like radio frequency and to give us so we know exactly where it is. But the gyroscope is going to give us a relative position, where in the field and how it's going.
Why wouldn't you just put GPS on there?
GPS is not accurate enough to determine something in that small of an area. So I can look at my phone and it might say that I'm outside the building, so I wouldn't trust that to tell you exactly where it's at. So, and we need navigation really needs to be two parts. It needs to have regional positioning and absolute positioning. Yes?
So what is the status of the project? Can you build the system and tested it or what?
We have right now the chassis and the Arduino controller, and we have a couple of the sensors. It's not working as well as it should yet. Right now the ultrasound sensor, it looks like the one we got isn't working, so we're probably gonna have to replace that.
So right now we have it driving around, and we haven't had the algorithm for the pathing, but we can just give it a path right now.
Have you done any background reading in terms of what Department of Defense has supported for this, and also NSF has a very large program on ground penetrating radar for both plastic and
Well, I was a combat engineer in the Marine Corps, and I was trained in detecting landmines. And they did have a ground penetrating radar, a metal detector, landmine detector, but that thing was very bulky and would be cost prohibitive for us. Our goal is really to make something that's cheap enough that third world nations can afford it. And that's mainly, there are systems out there that are designed to detect landmines, but we're working on a limited budget so that way other people can use it. Our primary customer is not the U.S. military. Yes?
What's the most expensive part on there? Is it the metal detector?
No, it is actually the wild thumper chassis.
Okay.
It's a 6-wheel off-road drive, and each wheel has its own motor, so it's really good at going pretty much anywhere.
It will be on display outside.
All right, so I guess time is expired.
All right, thank you.